So, welcome to another lecture. In this lecture, we'll be doing a very basic topic, fractional addition and subtraction. So, it's a basic topic, but I've seen a lot of senior grade students also struggling, maybe class 7th, 8th, 9th, 10th. Students also suffering. So, we'll do basic fraction addition. And then, in the end of the lecture, what I'll try to do is I'll try to explain you how to add the algebraic fractions also. Now, if you are a class 7 student, then you would be required to understand this also. Otherwise, if this kind of fraction is algebraic fraction is not in your syllabus, you can skip it and you can focus on this part. So let's start. I'll be providing you a worksheet that will be there in the comment section. Please practice as much as you can. In maths, the more you practice, the better it is. So the first thing that we need to understand before we even start fractions is taking LCM. Taking LCM. I have a separate lecture on LCM. You can have a look at that also. I'll mention the link in the comment section. Here I'll give you another introduction to LCM. So LCM is the lowest common multiple. Lowest common multiple. So this seems to be tricky, but is a very simple topic. So what it is trying to say is, I'll take a very simple example to explain this. So for example, I have to find the LCM of 3 and 5. 3 and 5. So we'll go one by one. So first thing that is mentioned in LCM is a multiple. So the multiples of 3 are 3, 6, 9, 12, 15 and so on. Basically the table of 3. The multiples of 5 are 5, 10, 15, 20, 25 and so on. So you have written the multiples of 3, you have written the multiples of 5. Now you have to find the common multiple, and it should be the lowest also. So basically we have to find the lowest common multiple. Now if you look at here closely, the lowest common multiple is 15. So the LCM of 3 and 5 would be 15. Let's take another example. Let me find the multiples LCM of say 2. I'm taking very simple example so that you understand the concept. 2 and 10. Now you can write the first multiples of 2. So 2, 4, 6, 8, 10 and so on. Multiples of 10, 10, 20, 30, 40, 50. Basically the tables. Multiples is basically finding the table of a particular number. So now again we have written the multiples, and now we have to find the lowest common multiple. Basically the first number which is in this sequence, the first number which is common. So if you see 10 and 10, they are common. So the LCM of 2 and 10 is 10. Now there is a word which I want to introduce. I think many of you might not be familiar with this, but it's good to understand this term. The term is coprime. What coprime means is that if you take two numbers, for example 3 and 5, and basically they don't have any common factor except 1. So if you look at 3 and 5, they are coprime numbers because they don't have a common divisor. The only common divisor is 1. But if you look at 2 and 10, there is a common divisor which is 2. So 3 and 5, they are called coprime numbers. I won't go into details, but I want to introduce this word into your terminology. There is something called coprime numbers. So you can skip the topic. Coprime is not something very important, but at least you should understand. But 2 and 10, they are not coprime. Now coming back to LCM. For example, we have to find LCM of say 4 and 10. Very simple numbers. So again, you can write the multiples of 4, 8, 12, 16, 20 and so on. And multiples of 10, 20, 30 and so on. Now, if you look closely, which is the first common multiple? The first common multiple is 20 here and 20 here. Is there anything else? 4, 8, 12, 16? No. 10, 20? Nothing. So the LCM would be 20. Let's find LCM of another group of numbers. For example, say 15 and 10. 15 and 10. So I'll write the multiples of 15. 15, 30, 45 and so on. Multiples of 10, 10, 20, 30. I try to figure out, pause the video, try to figure out. So basically what I'm trying to tell you is I'm just trying to introduce the concept of LCM as slowly as is possible. Then we'll do a method, because as you would understand, this is a bit of a tedious method, because you have to write the multiples of first few multiples of both the numbers. So this is a bit tedious method. There is a shortcut that will come, and I hope you will have found the LCM. So the LCM 15, 30, 45, 10, 20, 30. So the LCM would be 30. So now we have done 4 examples. 3 and 5 LCM is 15. 2 and 10 LCM is 10. Let me mark it in black. So this is the first set of number that we'll be using this again. We'll be using these set of numbers again. The LCM of 2 and 10 is 10. The LCM of 4 and 10 is 20. And the LCM of 15 and 10 is 30. So this is how you introduce the concept of LCM, that basically it's a common multiple, but it's a lowest common multiple. Let me try to go deeper and try to tell you what am I trying to say is a lowest common multiple. So let me take example of 4 and 10 again. 4 and 10 again. To let's go a bit deeper. Not much deep, not very deep, but a little bit deep. So 4 to the 8, 4 to the 12, 4 to the 16, 4 5 the 20, 4 6 the 24, 28, 32, 36, 40. So these are the first few multiples of 4 that I have written. Multiples of 10 are 10, 20, 30, 40 and so on. Now look closely, you will understand what I am trying to say. If you want to find the common multiples of 4 and 10. So if you look closely, the first common multiple is 20. Here you have 20. Then you have 40. Then you have 40. So the common multiples are 20, 40, and if you are getting it, basically 60 would be another number, 80 would be another number, and so on. But in LCM, when I'm trying to find the LCM, what I'm trying to find is the lowest common multiple. What I'm trying to find is the lowest common factor. So the lowest common factor would have to be 20. And that is what is the meaning of LCM. That is what is the meaning of LCM. You have to find the lowest common multiple. The lowest common multiple. I hope now it's clear. I'll give you a few practice questions also. Another thing which I want to specify is, because I want to make it as beginner friendly as possible. So I'm avoiding 3-digit numbers. If you want to find LCM of 3-digit numbers also, you can find the LCM of 3-digit numbers also. Let me take example of 2, 5 and 10. See, the process remains the same. You can take 2, 5, 10. You can take 2, 5, 10, 15 also. The process will remain the same also. So let me illustrate you with the example of a group of 4 numbers. Process will remain the same. The process won't change. But don't worry about it. So you'll have to write the multiples of 2, 5, 10, 15. You'll have to write the multiples, and then you will have to find the lowest common multiple. The process will remain the same. Try to find the LCM. And then let's proceed. We're able to do it. So I've written the multiples of 2. You can check multiples of 5, multiples of 10, multiples of 15. And I hope you were able to find that the LCM is 30. Now, as you will understand, as I have told you before, if you have to find the LCM of 2, 5, 10, 15, and you use this method, it will be a very tedious method. In the exam, you will be doing this only. So I hope you are able to understand the concept of taking LCM. How do you, what's the meaning of lowest common factor? But using this, method of writing all the multiples of a number and then finding the lowest common factor is a very tedious job. So, what's the shortcut? And now let's try to find the shortcut. Let me take the first question only, the last example that I have taken to start. So, what you do is you write the numbers. So, for example, I have to find the LCM of 2, 5, 10, 15. So, I write the four numbers. See, this is not minus, this is just a dash. Dash is basically there to just separate the four numbers. But the first thing that you do is you try to take a common multiple. And this method is called LCM by prime factorization. So what I am doing now is called finding LCM by prime factorization. So I hope you know the meaning of prime. So prime numbers are numbers like 2, 3, 5, 7, 11, 13, 17, 19. These are the only numbers that you will require in let us say 95% of the questions that you will be doing. I'll say 98% of the questions that you will be doing. These are the only numbers that you will be requiring. These are the only prime numbers you will be requiring. It's only at time that they go to 23. I haven't, and that too are very tough questions. So usually when you are trying to find LCM by prime factorization. Usually, these are all the numbers that you require. You require 2, 3, 5, 7, 11, 13, 17. So these are the prime numbers that you require. Not even 17. At times, process basically stops at 13. So finding LCM in this process of finding LCM by prime factorization is you list the numbers, you separate them by dashes, and then you draw these lines, a vertical line and a horizontal line. And you try to find the first prime factor which divides two or more of the numbers. So for example, the first prime number that I can see which divides two or more the numbers is 2 and 10. So the prime number is 2. So I'll say 2 ones are 2. Now I'll write 5 as it is because 2 doesn't divide 5. But 2 5s are 10. And I write 15 as it is. I hope this is clear. So I divide 2 by 2. 2 ones are 2. 5 is not divisible by 2. 10 is divisible by 2. So 2 5s are 10. And 15 is not divisible by 2. Now I look at the next lot of numbers. And I try to find a common factor which divides two or more numbers. As you can understand, that number is 5. So 5 ones are 1 is as it is, 5 ones are 5, 5 ones are 5, 5 3 are 15. And then I just have a single number, so I'll write 3. So this is as it is and 3 ones are 3. Now what I suggest to students is that if they do this method properly, write the numbers one below the other in a symmetrical fashion. Write it like this. Don't write zigzag. Otherwise, you'll make a mess of the process that you are following. Now, what will be the LCM? The LCM would be 2 multiplied by 5 multiplied by 3. So 5 3 is 15, 15 2 is 30. The LCM is 50. Here also, if you see, the LCM was 20. So this is a shorter method rather than writing all the common divisors. I'll be using these same numbers when I'm doing the addition of fractions also. So don't worry, this will be very useful for me. So please try to do with me all the questions, because we'll be using the same set of numbers to find the addition of fractions. Now let's apply prime factorization to the other numbers also. So I'll apply prime factorization for 15 and 10. So 15 and 10, I separate them by a dash. Then I draw a horizontal line and a vertical line. Was it the first prime number which divides the two numbers? The first prime number. 2 is not there, 3 is not there, 5 is there. So 5 3s are 15, 5 2s are 10. Now I will rub this to make some space. Now, is there a common factor of 3 and 2? No, there is no common factor of 3 and 2. So what I can do is I can write LCM. So once you have reached a stage where there is no common prime factor, then you can just multiply the three numbers which are remaining. So LCM is 5 into 3 into, so 3 to the 16, 3 to the 6, 6 5 is 30. So the LCM is 30. As before, the LCM is 30. Before also we found the same LCM 30. Please try to do uh, try to do whatever I am doing on the screen on your own, because that will help you when we are doing the fractional addition also. It will help you a lot. Now let's find the LCM of 4 and 10. So again, I'll have to draw, let me draw here. So 4 and 10. The first common prime number which divides both the numbers, that is 2. 2 2s are 4, 2 5s are 10. Now, is there a common factor of 2 and 5? No, there is no common factor of 2 and 5. So what will be the LCM? The LCM is, just multiply these three numbers. So 2 into 2 into 5. So 2 2s are 4, 4 5s are 20. The LCM is 20. This LCM is the same as we had done. Now let's find the LCM of 2 and 10. Let me make some space so that there is no confusion. LCM of 2 and 10. Write the numbers. Write the numbers. Find the first prime number that divides both these. The first prime number is 2. 2 1s are 2, 5s are 10. And now the process stops because 1 and 5 are there. So the LCM would be multiplied by 5. It will be 10. So here 10. LCM would remain the same, any method that you find. Now 3 and 5. See, 3 and 5 are basically co-prime numbers. So whenever you meet any co-prime numbers, you can just multiply the numbers. In the practice set that I will be giving, I will be mentioning a few set of co-prime numbers also, so that you can have a look at the PDF also. So otherwise, if we follow the tabular method, so 3 and 5, there is no common divisor, no prime factor divides, no common prime factor of 3 and 5. So I just have to multiply, so my answer would be 3. So we have found the LCM of 3 and 5, 2 and 10, 4 and 10, 15 and 10. Then we took a 4 digit and found the LCM. I'll mention few practice questions in the PDF also. You can practice that also. See, LCM, finding LCM is a critical part of addition or subtraction of fractions. Let me take few more examples so that things are clear. Let me take example of say let me take example of 21 and 45. 21 and 45. Try to do on your own. Pause the video, try to do on your own, and if you are not able to find, then please look at the solution. So 2 and 45, I have separated them by a dash. Then I draw the vertical and horizontal lines. The first prime factor which divides both them. So the prime factors that I have are 2, 3, 5, 7, 11, 30. So you have to start with the lowest. 2 doesn't divide 21 and 45. 3 does. Now, is there a common factor of 7 and 15? No, there is none. So the LCM would be 3 into 7 into 3. So you find the number and that is the answer. So 7 3 is 21, 15 1s are 15, 15 2s are 30, 3 1 5, 3 7 5 are 35, 3 1 5 is the answer. So I'll give you a set of few numbers for whose LCM you can find. Please try to practice that if you are completely a new beginner. And then there is another thing that you need to understand is there is something called divisibility roots. Divisibility roots. Divisibility roots. I'll also attach. I have a lecture on divisibility roots. Please find that in the comment section because when you are trying to find the common factor, you will have to look at that divisibility rules also. So you can refer to that lecture also. So till now we have understood what are LCM, and now using this concept of LCM, we'll start doing fractional addition and subtraction. So let's start. Now that we have understood the funda of finding LCM, we'll be doing the addition and subtraction of these fractions A, B, C, D, E. Addition and subtraction of these fractions. See, one thing that I need to clarify is the denominators are the same that we had taken above. So 3 and 5 was the first group of number for whose LCM we had taken. This is 5. So 2 and 10, 4 and 10, 15 and 10, 2, 5, 10, 15. So we already have the LCM of these numbers. Now we'll be doing trying to find the LCM of these numbers. Before I proceed, there is some other information that I want to share with you. So the concept of like and unlike fractions and the concept of equivalent fractions. So quickly we'll go through this also, and then we'll come back to this, because I want you to go step by step when you are doing this concept, because this is something very fundamental, and I've seen a lot of students who are struggling. I've met class 10 students who are struggling with fractions. So please try to understand as best as you can and try to practice. You can use a worksheet which is given in the PDF. Please use it. There are answers available. So put some effort to understand this. So equivalent fractions. So see, there's a property of fractions. So for example, if there's a fraction like 3 and 5, there's a property of fractions. I can multiply the numerator and the denominator by the same number. So I can take the numerator. So I hope you know, this is called the numerator. The number above is called numerator, and the number below is called denominator. So the property of fraction is, I'll specify this again. You take any fraction. So for example, now let's take 5 by 7. Now 5 by 7 would be equal to 5 into 3. 7 into 3 would be equal to 5 into 6. 7 into 6 would be equal to 5 into 11. 7 into 11. So what I'm trying to tell you is that you take any fraction, you multiply the numerator and denominator with the same number. So for example, here I have multiplied the numerator and denominator by 3. Here I have multiplied the numerator and denominator by 6. Here I have multiplied the numerator and denominator by 11. Sorry. So basically what I'm trying to tell you is that all these fractions, that is 5 by 7 and 15 by 21 and 30, 42, 55, 77. So all these fractions, they are the same, and this is what is called equivalent fractions. Equivalent fractions. So what is the meaning of equivalent fraction? Take any fraction, 3 by 5. You can multiply the numerator and denominator by the same number. 3 into 7, 5 into 7. So these fractions, 3 by 5, 9 by 15, 21 by 35, these would be called the equivalent fractions. Equivalent fractions. Equivalent fractions. So we have understood the concept of equivalent fractions, and now let's understand the concept of like and unlike terms. So like and unlike fractions are very simple. So for example, 3, 5, 2, 5, they are like fractions. 7, 5, 9, 5. The denominator is the same. So they are like fractions. Another example, 5 by 7, 6 by 7, 15 by 7, 12 by 7. So these are like fractions. Now, these are what are called like fractions. Like fractions. The denominator is the same. If you want to know what is unlike fractions, if the denominators are different, then they are unlike fractions. So for example, 15, 25, 35, 45. Now they have become unlike. So like fractions, unlike fractions, equivalent fractions. I'll add few questions from like, unlike equivalent fractions in the PDF, so please have a look at that also. As I've tried to tell you again and again, please practice these concepts as much as you can. This might be a bit long video, but try to spend some time on this very important topic. Okay, now that everything is clear, now let's try to understand how do we add 2 by 3 and 4 by 5. 2 by 3 and 4 by 5. 2 by 3 plus 4 by 5. So first thing that we need to do is we need to make these like fractions. We need to make these like fractions. What is the meaning of like fractions? The denominator are same. Denominator are same. So basically, what we need to do is we need to make the denominator of first fraction and the second fraction to be the same. If the denominators are not same, I can't add as easily. So for example, let me here give you an example of a simple fraction. So for example, if I had to add these, now these are like fractions. Adding like fractions is very easy. All that you need to do is, this is the common denominator and then just add the numerator. So 5 plus 4 is 9. That's it. Very easy. So adding like fractions is super easy. Because you don't have to do anything. Just write the denominator and simply add the numerator. So for example, 6 by 7 minus 4 by 7. Take the denominator and just subtract. 6 minus 4 is 2. 3 by 7 plus 4 by 7 minus 5 by 7. Just take 7. 3 plus 4 is 7. 7 minus 5 is 2. So the answer would be 2. So adding or subtracting like fractions is super easy. Because the denominator is the same. But then when you have unlike fractions, then your first step is to make the denominator same. So 3 and 5 have to be converted into such numbers so that we can make the denominator same. So 2 by 3 plus 4 by 5. So we have understood that make these like fractions. So this is the first step. Convert these into like fractions. How do we convert this into like fractions? The first thing that we do is find the LCM. Now, as we know, this is what I was trying to tell you before. The LCM of 3 and 5 is 15. Now, 15 is the magic number. You have to find the LCM of the denominators. Because we have already discussed LCM. Now, I won't go into the detail. The LCM of the denominator 3 and 5 is 15. Okay. Now, I have to make this fraction 2 by 3 into an equivalent fraction so that the denominator is 15. What I am trying to tell you is that I have to convert this 2 by 3 into its equivalent fraction with the denominator 15. So 3 5s are 15. So same number has to be multiplied by numerator also. So 2 multiplied by 5 is 10. I hope this is clear. What did I do? I knew that this is 3 multiplied by 5. So same number, because I want equivalent fraction of 2 by 3. So equivalent fraction of 2 by 3, which has a denominator 15, is 10 by 15. Similarly, I take the second fraction, 4 upon 5. I want to find the equivalent fraction of this. The equivalent fraction should have the denominator as 15. So 5 3s are 15. So 4 3s are 12. So 12 by 15 would be the equivalent fraction of 4 by 5. You need to understand that the denominator of both these should be same. And now it has become same. So now I can, basically what I have done is, in short what I have done is, 2 by 3, 4 by 5, I have converted this into 10 by 15 plus 12 by 15. 10 by 15 is the equivalent fraction of 2 by 3. 12 upon 15 is the equivalent fraction of 4 by 5. And now because these two are like fractions, These two are like fractions. So now the denominator would be the same and they can be added. I hope the process is clear. So what was the first step? Let's review this again. Let's review the process again. Let's review the process again. So I found these two fractions. I had to add these two fractions. So what was the step 1? So step 1 was make these into like fractions. Step 1 was make these into like fractions. This is what I want to do. But to have this, what do I need? I need to take the LCM. Take LCM. LCM of what? LCM of the denominators. 3 and 5. Once I have taken the LCM, then I know that I want equivalent fraction of both these fractions. What is the step 3? Step 3 is equivalent fractions. Equivalent fractions. Once I have formed the equivalent fractions, then basically I'll get two like fractions and I can write the denominator and just add the numerator. Let me explain you with another example. We explain to you with this example, half minus 9 by 10. Half minus 9 by 10. Half minus 9 by 10. So I want to convert these into like fractions. For like fractions, I have to take the LCM. I have taken the LCM. You can look at the LCM. The PDF would be there in the comment section. The LCM is 10. So basically, I have to find equivalent fraction of half whose denominator is 10. So 2 5s are 10. So 1 into 5 would be 5. Now see, 9 by 10, the denominator is already 10. So I don't need to convert it. So I will write this as 5 by 10 minus 9 by 10. And this would be equal to minus 4 by 10. And what is always advisable is that if you have a fraction which has common divisors, the common divisors have to be taken out. So the common divisor is 2. So 2 2s are 4, 2 5 are 10. So minus 2 by 5. Final answer. So let's go to the next question. 3 by 4, 7 by 10. 3 by 4, 7 by 10. 3 by 4 plus 7 by 10. So again I know that the LCM of 4 and 10 is 20. I hope you are able to connect the things. So what does LCM do? LCM help us make the denominator same. Helps us convert these unlike fractions into like fractions. We know the direction in which we have to. So basically I have to convert 3 by 4 into such a form so that the denominator is 20. Similarly, I'll take 7 by 10 and I have to convert it into a fraction so that its denominator is 20. So 4 5s are 20 and therefore 3 5s are 15. 10 2s are 20, so 7 2s are 14. So 15 by 20 is the equivalent fraction of 3 by 4. Let me write it here. So equivalent fraction of 3 by 4 is 15 upon 20 and equivalent fraction of 7 by 10 is 14 by 20. And when I add these two, denominator is the same. 15 plus 14 is 29. So 29 upon 20 would be the final answer. So let's do this now. 11 upon 15 minus 7 upon 10. 11 upon 15 minus 7 upon 10. So LCM equal to 30. I know I have done this before. Again, please pause the video, try to do this on your own and check the answer. So 11 upon 15 into 2 into 2, 7 into 3, 10 into 3, 22 upon 30, 21 upon 3. So this will be equal to 22 minus 21 upon 3. This is the final answer. So similarly, you can do as many questions as you can. As I told you earlier, the PDF would have a lot of practice questions that you can try to do. And for example, this is a question you should try to do. You know the LCM of these numbers. LCM is 30. Here the LCM of 2, 5, 10, 15. LCM is 30. So basically, all these would have to be converted into fractions with denominator 30. So here you'll have to multiply the numerator and denominator by 15. Here you have to multiply by 6. Here you have to multiply by 3. Here you have to multiply by 2. So that the denominators is 30. Then you just add or subtract as is required. So the more practice that you do, the more you'll understand. And so basically we are able to do this. Now, how do we do questions like these? See, these questions are very simple. All that you need to do is write 4 as 4 upon 1. 4 upon 1. So the LCM of 1 and 3 would be 3. So just make this into an equivalent fraction whose denominator is 3. How will you make it? So 4 into 3, 1 into 3. So this will be 12 upon 3. So 12 upon 3 plus 2 upon 3. So that will be equal to 14 upon 3. Now here the mixed fraction is given. Convert this into improper fraction. So 2 to the 4 plus 5. 5 upon 2 plus 3 upon 1. So find the LCM. The LCM would be just 2. And then proceed. So let me show you a few questions from the worksheet which you should try. We'll discuss few questions and then you can try the rest of them on your own. So this is a PDF that you will find. And these are the kind of questions here. So for example, let's look at question number 3. So 5 by 8 plus 7 upon 12 minus 3 upon 16. So when we have to tackle this kind of fraction, another thing is that answers to all the below are given here, and you'll have to draw a line like this. So 17 by 36, this is 49 by 48. So just take care of this. So this is 7 by 15. In few of the questions, the line is missing. So just take care. So this is 13 by 20. This is 5 by 12, 7 by 13. This is what you have to manage on your own. So when I have to, as you know that the first step that you need to do is reduce these to the like fractions. So this is the core that you are trying to do. How do you convert this into like fraction? You take the LCM. You take the LCM of 8, 12, 16. You put dashes in between. This is finding LCM by prime factorization. And then this is the smallest prime number which divides all of these. So 2. So 2 4s are 2 6s are 2 8s are again 2s are 2 3s are 2 4s are again 2. And finally 3 and 2, they don't have any common divisor. So my LCM would be 2 into 2 into 2 into 3 into. So 2 to the 4, 4 to the 8, 8 to the 24, 24 to the 48. So my LCM would be 40. So what is what is the next challenge? The next challenge is to reduce these denominators to 48. Basically, I want the equivalent fraction of 5 by 8, 7 by 12, 3 by 16, so that the denominator is 48. So 8 6 are 48, so 5 into 6. 12 4s are 48, so 7 into 4. 16 3s are 48, so 3 into 3. So this will be equal to 30 upon 48. This will be equal to 28 upon 48. This will be equal to 9 upon 40. So in short, what you have done is you have reduced these above, the above three fractions into this format. So 30 upon 48 plus 28 upon 48 minus 9 upon 48. So equivalent fraction, equivalent fraction, equivalent fraction. Now the denominators are the same. So you'll write 48 here. 30 plus 28 minus 9, and you'll finally find the answer. So this would be 30 minus 9 is 21. So this is 49. So 49 upon 48. Question number 3. 49 upon 48 is the final answer. Just take care to add 37 by 42. This is 13 by 16. This is 8 by 9. So this is what you will have to take care. So practice these 25 questions, and you should have enough practice. And finally, we'll spend some time, not much detail. We'll just spend some time. Maybe I'll make a separate lecture on this. So if I have to find the value of x by 2, we use space here, x by 2 plus 3x upon 5 is equal to 7. So here I have to add two algebraic fractions. Everything remains the same. LCM of 2 and 5 is 10. So basically, the denominator of both these fractions should be 10. How can I make it 10? So 2 5s are 10. So 5x plus 5 2s are 10. So 3 into 2, 6x is equal to 7. The right hand remains as it is. So this is 10. So numerator would be 5x plus 6x. That will be equal to 11x is equal to 7. 7 can be written as 7 upon 1. Now I do cross multiplication. So 11x is equal to 70. X is equal to 70 upon 1. So this is how you can add the algebraic fractions also. See, my intention of this lecture is to make it a very simple lecture about LCM. This is just a glimpse of for senior students that same logic can be applied to add algebraic fractions also. And maybe we'll do a separate lecture about this where we'll go into detail. So finally, I hope you found this lecture useful. I'll just take you through whatever we have discussed again. So first concept that we learned was how to find the LCM. Started from there. There are few other things that we learned. We learned the concept of co-prime. What are co-prime numbers? We learned that LCM is basically the lowest common multiple. One way of doing is a very basic rudimentary way of doing this is that you write all the multiples, which becomes, as you have understood, which will become very tedious. So the shortcut of finding LCM is that you find LCM by prime factorization. In prime factorization, you use the prime numbers 2, 3, 5, 7, 11, 13, 17. They act as a common divisor. Then there is a format that has to be, the number should be separated by dash, and all the things should be in order so that there is no confusion. So we understood the concept of LCM. There is another thing which I told you. Please, you should be very good with the divisibility rules. If you have any doubt, please look at the divisibility rules lecture which is given. Then what we understood was the concept of equivalent fractions. We understood what are like and unlike fractions. Once we had done all this, LCM, equivalent fractions, like, unlike fractions, only then we can understand the fraction, the addition and subtraction of fractions. I've intentionally made this lecture long because I want to my intention was to start from absolute basic and try to build up the concept from the core. And as I've told you many times during this lecture, the more you practice, the more you'll understand the concept. And these try to do these. The answers are given, and best of luck. Please have a look at the other lectures also on this channel, and please subscribe. Please share this video, and let's meet again in the next lecture. Thanks a lot for watching. Best of luck.